Hello everyone, today we are going to look at theory of quadratic equations. This is the second part of theory of quadratic equations, and now we look at the method for solving quadratic equations with examples. Quadratic equation is defined as ax squared plus bx plus c equals 0, where is the quadratic coefficient, b is the linear coefficient, c is the constant term or the free term, provided a not equals 0. If a equals 1, then it is a monic quadratic equation. Otherwise, it is a non-monic quadratic equation. The methods we are going to consider now are quadratic factorization, completing the square, quadratic formula, and graphical solution. The graphical solution of quadratic equation has a parabolic curve. If a greater than 0, then the parabolic curve of the quadratic solution bends outward, as we can see from this diagram, and the top part of it is called the vertex. Now let's look at this example that we have 3x squared plus 2x minus 7 equals 0. In this case, a is 3, positive 3, which is greater than 0, and in that means we are going to have a kind of a smile. But what kind of a smile are we going to have? We are going to have a positive smile. Now let's consider if a is less than 0, then the parabolic curve of the quadratic equation bends inward, as we can see in this. Now let's consider this example of 6x minus x squared plus 18 equals 0. And in that case, we have our a to be minus 1, and that is going to give us a negative frown. Now let's move to the next part, discriminant. Let D represent discriminant, then D equals b squared minus 4ac. If D is greater than 0, we have the real roots. If D is less than 0, we have the complex roots. If D equals 0, we have the equal roots. And we'll look at this diagram where we have the D greater than 0, then we have the D less than 0, and we have the D equals 0. Consider D greater than 0, which produces two real roots, two solutions. Now the first case, if we have two negative real roots, we are going to have something like this in this diagram. If you look at it, that we have our graph on the negative part of x. It can bend inwards or it can bend outward. Now the next is the positive and the negative real roots, and in this case our graph is going to cut both the negative x and the positive x, so it can also bend inwards and also bend outward. And the last part is that we have two positive real roots, and in this case our graph only tends to the positive aspect of the x. It can also bend inwards or it bends outward. If d is less than 0, we have complex root, that means no real solution. The first case is that we have the negative complex root. If you look at the diagram, we have our graph on the negative x, so it can bend inward or it bend outward. Then the second case is we have positive and negative complex root, and if you look at this, we have our graph that tends to both negative x and to positive x. It can bend inward and it can bend outward. And the last case is we have the positive complex root. If you look at this, you have our graph on the positive x, so it can bend inward or it bend outward. If d equals 0, we have double root, that means one solution. The first case is if you have negative double root. In this diagram, we have our graph touching only the negative axis. It can bend inward or it bend outward. The second one is the zero root. In this diagram, we see that our graph is touching exactly the 0 of minus s and x axis. It can bend inward or it bend outward. And the last part is the positive double root. In the graph, we see that it only touches the positive x. It can bend inward or it bend outward. Let's consider the first method, the quadratic factorization. Quadratic factorization is factoring by grouping. We have the direct factoring, grouping, AC method. It can be the most difficult technique to solve quadratic equation if the equation is not simple. For instance, if the coefficients are large whole numbers, fractions, or roots, the right grouping may be difficult to find even if it exists. The next method is completing the square. Completing the square has a well-defined algorithm for ax squared plus bx plus c equals 0. Step 1, we divide each side by the coefficient of the square term. In this case, we divide by a throughout. Then step 2, we subtract the divided constant term from both sides. In this case, we take the c over a to the other side in order to have a negative c over a. Step 3, we add the square of 1/2 of the coefficient of x to both sides. It means we are going to add b over 2a all square on left and right hand side. Step 4, we convert the left side into a perfect square and simplify the right side if necessary. For the left hand side, we have this as the perfect square. And if we simplify that, we are going to have x plus b over 2a all square. And on the right hand side, when we simplify that, we are going to have b squared minus 4ac over 4a squared. Produce two linear equations by equating the square root of the left side with the positive and the negative square root of the right side. In that case, we're going to have x plus b over 2a equals plus or minus square root b squared minus 4ac over 2a, which implies x equals minus b plus or minus square root b squared minus 4ac over 2a. Step 6. Solve each of the two linear equations. We have x equals minus b plus square root b squared minus 4ac over 2a, or x equals minus b minus square root b squared minus 4ac over 2a. Now we move to the third method, quadratic formula, applying the algorithm of completing the square on ax squared plus bx plus c equals 0. We result to a quadratic formula x equals minus b plus or minus square root b squared minus 4ac over 2a. Remember that quadratic formula may not completely stable if b squared and b squared minus 4ac have close magnitude. Let's solve the following quadratic equations. We are going to consider only 3 equations for our examples. Let's consider quadratic factorization for example. X squared minus 3x minus 4 equals 0. In this case, we multiply x squared with a minus 4, and we're going to arrive at minus 4x squared. Now we consider two factors. When we multiply, we get minus 4x squared. When we add up, we're going to get minus 3x, and that will be plus x and minus 4x. Next, we need to take the x squared and the minus 4 beside our factors, and that will definitely give us x squared plus x minus 4x minus 4 equals 0. The next thing we have to do is we factorize the equation to have x into bracket x plus 1 minus 4 into bracket x plus 1 equals 0. Then we have x plus 1 and x minus 4 equals 0. When we solve that, we are going to arrive at x equals 4 or x equals minus 1. Using completing the square for x squared minus 6x minus 10 equals 0. The coefficient of x squared is 1, which has no effect in the division. Then we add 10 to both sides to have x squared minus 6x equals 10. Next, we add the square of 1/2, the coefficient of x, which is minus 6, to both sides. Then in this case, we're going to have x squared minus 6 plus minus 6 over 2 all square equals 10 plus minus 6 over 2 all square, which will arrive at x squared minus 6x plus 9 equals 90. We need to convert the left side into a perfect square and simplify the right side if necessary. X minus 3 all square equals 19. Square root both sides. We're going to have square root of x minus 3 all square equals square root of 19, which will give me x minus 3 equals plus or minus square root of 19, which will be x equals 3 plus or minus square root of 19. Therefore, the roots of the equations are x equals 3 plus square root of 19 or x equals 3 minus square root of 19. Quadratic formula to solve 3x squared plus 2x minus 7 equals 0. To solve the above equation using the quadratic formula, we'll let a to be 3, b to be 2, and c to be minus 7. Then we have x x equals minus 2 plus or minus square root of 2 square minus 4 into bracket 3 into bracket minus 7 over 2 into bracket 3. Then we have minus 2 plus or minus square root of 88 over 6. When we simplify that further, we have 2 into bracket minus 1 plus or minus square root of 22 over 6. Then we have our x to be minus 1 plus square root of 22 over 3, or x equals minus 1 minus square root of 22 over 3. Now solve the following quadratic equations using factorization, completed square, and quadratic formula. We're going to time you, but right now, pause the video, try the questions, then we're going to give you the solution. These are the solutions. I believe you also got the same. Please, if you like this video, click on the subscribe button and the like button for more videos.